RCWM Rainwater Conservation Mesh Wells Module. Aquifer recharge and aquifer storage and recovery. Reduce surface runoff. Mitigation the probability of flooding caused by heavy rain. RCWM Rainwater Conservation Mesh Wells Module. Provide the most economical and simple solution. RCW Rainwater Conservation Mesh Well System that is used to transmit surface water underground and is deeper than its width at the surface. Most RCW are 5 to 20 meters deep and 4 inches to 12 diameter mesh drainage pipe. They are lined with anti-clog mesh and can be filled with gravel or rock or left empty. Today, RCW usually includes some form of pretreatment to remove oil, particles, and associated contaminants, reducing the risk of clogging the wells and of transporting contaminants underground. Environmental and human benefits. RCW Rainwater Conservation Mesh Wells System can be used to reduce the probability of flooding caused by heavy rains and reduce the adverse effects of stormwater runoff on streams and rivers. Capturing urban stormwater prevents the runoff from entering streams and lakes where contaminants could cause pollution and erosion could damage aquatic habitats. RCW can also be used to return water to aquifers. A single RCW can transmit a lot of rainwater. This ability to recharge local groundwater supplies can help increase water resource security by mitigating the effects of drought or excessive groundwater extraction. The structure of RCWM. RCWM, Rainwater Conservation Mesh Wells Module, composes of vertical mesh wells and horizontal arched mesh pipe. It collects rainwater that then infiltrates the subsoil and finally percolates to aquifer. Mesh well are the artificial vertical infiltration facilities can not only set a better penetration of the effective storage, can also be used as horizontal arched mesh pipe connection between the nodes, which can accommodate drainage sludge generated during debris removal to maintain a regular basis to facilitate smooth drainage. Usually, mesh well and arched mesh pipe with a rainwater conservation mesh wells module to collect on the surface rainfall and saturated ground in the infiltration of rainwater to ground. Water layer. The principle of RCWM is to collect rainfall from surface first, and then make the saturated groundwater percolating into aquifer. The arched mesh pipe manufacturing principles. Traditional subsoil pipes are dug holes around the pipe. They must come along with gravel and other non-woven filter material coated to prevent pipe blockage. The arched mesh pipe uses half-moon shape design. The half-moon part is impermeable layer and the flat part is permeable layer. When constructing, the flat part of the mesh lies down. It results in soil particles sinking due to gravity and not going with water into the aqueduct. Therefore, water chamber can solve the problem of underground drainage pipe blocking without filter material and clog resistant. Unique characteristics of RCW mesh well. Anti-clog mesh well features. The sidewall has T-type thread design and high compressive resistance. The sidewall openings are high-density mesh design. Mesh well sidewall anti-clog design minimizes soil entering without extra filter material, such as non-woven fabric. Introduction. Aquifer storage and recovery. ASR is defined as the storage of water in a suitable aquifer through a well during times when water is available, and recovery of the water from the same well during times when it is needed. Essentially, excess fresh water is infiltrated and stored in aquifers through wells or infiltration ponds, and recovered from the same wells when needed. Increasingly applied worldwide, it is often considered the technology of choice because water can be stored for extended periods of time and recovered as needed. There is insufficient above-ground storage space. Water is well preserved, e.g. no algae growth. The stored water is protected from external influences, such as temperature fluctuations, evaporation, contamination. It eliminates the need for expensive water treatment and prevents the buildup of waste streams. It helps create above-ground space for collection of peak precipitation and prevents the loss of precious fresh water. The technology is used in areas where the original groundwater quality is poor due to high salinity levels, or where the quality is suitable, but net extraction can cause damage as a result of dehydration. In the Netherlands, this technology is applied primarily at drinking water companies and increasingly in the greenhouse sector, where large quantities of rainwater are captured on the greenhouse roof and used as an ideal and low-cost source of tap water for irrigation.